All right, so welcome back, everybody. I trust that you're hearing me, Miss Morris.
I'm hearing you,
Okay, and Miss Anna Shea is hearing me. Mr. Authors, are you hearing me? Okay. All right, so I was just saying that when we're measuring these measuring instruments will become relevant to the size we are measuring. So when we're measuring like the length of a table, a meter rule, or measuring the length of fabric, the meter rule might be sufficient. But if you're trying to measure like the length of a racetrack, like for a 100-meter racetrack or a 400-meter racetrack, then a meter rule, even though you can use it, would not be the very best instrument to measure it, a racetrack. So that unit of the meter, even though we can use that unit and we count out 100 meters down a straight path, we could also decide to measure it in hectometer. Now, hectometer would be what? Hectometer would be 100 meter, right? So 100 meter would be actually 1 hectometer. You follow what I'm saying?
yes, sir.
Right. Yes. So why we have these varying prefixes is based on the relevance of what we're measuring. Now, if you're measuring, say, for instance, if you're measuring the length of like your fingernail, a meter rule, even though you can use a meter rule, it wouldn't be the best ruler to use. You'd probably use a centimeter ruler, right? And a centimeter ruler would be 1 centimeter would be 100 of a meter, meaning that you'd have 1 meter cut it in 100 parts, and that one length of the 100 parts, you cut the meter. So think of the meter rule itself, that you cut it up into 100 equal parts. Then one length of that now becomes a centimeter. And you can get a good sense of what a centimeter is by looking at a centimeter rule, because a centimeter rule is a little bit more than, like, say, a centimeter is somewhere close to probably about a half of an inch or so on. All right. But whereas a meter would be about 3 feet, 1 centimeter would be half of an inch, then you can see the relevance to have centimeter, because when you're measuring smaller things, you don't want to be struggling with a meter rule to measure smaller things. And if you are even to measure smaller things than a centimeter, you may want a device that can measure very, very small things now. So you may have to cut up a centimeter into smaller units, called millimeters, right? And if you are to go now on a microscopic level, where you're looking at probably the size of a sperm, you may want to now use other measurement like micrometers and so on, because those measurements now are taken into consideration small distance that you can barely see with your naked eyes, right? So in science, because we are measuring things that are both large and small, we want a measuring system that can span these various measurements. And so the SI system is suited for that, because you will see that there are many multiples and submultiples in the SI system. As you can go 10 to the minus 12, which is way smaller than the centimeter and millimeter. You can go 10, you can go up to megameters, or even more, depending on what you're looking at. So we're saying that SI system is a system that allows scientists to be able to measure very large or very small things with the convenience of powers of 10. All right. Now, we're now going to talk a little bit about basic quantities. We would have looked at some concepts. Anybody remember the concepts that we had looked at in the earlier part of the, well, I wouldn't be talking to Miss Anna today because today is our first official class, but at the beginning, maybe Mr. Authors was here for the first class, so you would have learned about various concepts. All right, so we talk about the concept of length, the concept of time, temperature, and so on. Now, these concepts can be measured. We can have measurement of these ideas. Like for time, we can measure time, we can measure temperature, we can measure what else we can measure? Length, we can measure mass, and so on. So these quantities of measurement, some we classified as basic quantities, and some we classify as derived quantities. So we're going to be looking at basic quantities and their units, all right? So here we have a little table of basic quantities. All right, now what really is a quantity? Can anybody tell me in their own words what they think of when we talk about quantities? What are we talking about?
The amount, sir.
Right,
the amount of something.
All right, but to extend it a little bit more than just amount of something, we can say those measurable things, the things that we can measure, right? And they come in various forms. So length is one thing that we can measure, mass is another thing. And so these quantities are not all of the same type, because length is when we are measuring linearly how long something is. Mass is when we are saying how much stuff of something is made of. And temperature, we're talking now about degree of hotness or coolness. Time, I mean, time is not something that we the way how we measure time, we talk about the time based on, can anybody give me an idea how we actually, the concept behind time, how that came about, and how do we get our time system? Where do we get that time system from? Anushe, you want to say something about time for us? Are you hearing me, Anushe? So Miss Morris, you're the only person who is interacting in the class. You see, we learn more when we interact and try to ask questions and get answers and so on. You know, just sitting there and listening to what I'm saying does not, well, it does not answer some things that may pop up in your mind. So when you think and ask questions, it helps you to explore more about various ideas. So I was just trying to get you to think a little bit more about time and how time came about. Why do we come up with this idea of time? So I'm just asking you now to share your views with me of what you think about time, how time came about, and why is time so important to us. Go ahead, Miss Morris.
I don't know how to explain it.
Okay.
Just know that time is non-stop.
Time is moving.
It's always moving.
Right.
How it is measured, I don't know.
And that's a very important point that you just made, you know. Because imagine that things stop moving. If everything just stuck and stop moving, you would say time stands still, you know that.
Yes, sir.
So that really telling you that time is dependent on movement. You follow? Because if we have a car coming from Montego Bay to Orchards, we can actually measure how long it takes to reach Orchards. Right? And we know that based on the driver, some driver can drive faster than some. So if the speed increases, then the time becomes less. Right? So time, distance, motion have some relation together. And our system of time, I'm not sure what is happening with Mr. Authors, but he's not hearing me. Can somebody just type in the chat and tell him to just log back in, just log out and log in. Oh, it's not Mr. Arthur, it's this Miss, that's Miss Morris. I hear what you're saying, Miss Arthur. No, my mic is not mute, you know. My mic is not mute. Anushe, are you hearing me?
Yes, sir.
All right. Miss Morris, are you hearing me yet?
Yes, sir. Your mic was muted.
No.
Yes, it says audio disconnected.
Yeah, the audio is disconnected, but it's not because my mic was muted. It has something to do with the network.
Okay. Sorry about that then.
Yeah, man. So because I was here talking and Mr. Arthur was responding in the chat, and Miss Anushe had confirmed that she was hearing me. So I know that something was wrong. But as you were saying, occasionally you kind of pop in and out. That's what seemed to be happening with Miss Morris. All right, so the idea of time really, I mean, from the moment mankind exists, they realize that things are moving, and so they come up with ways of how to measure how long it takes for something to move from one point to another. So, you know, the idea of time came about. And so we can trace our time system back to the Egyptian numeral system. Because when we talk about our calendar year is really based on the movement of different objects in our solar system, right? We talk about 1 year. 1 year would be what? What would be 1 year, Miss Morris?
12 months, sir? That's what you're asking?
Yeah, how do we measure a year?
How do you measure here?
Yes.
I'm not sure.
Miss
You're talking about the days?
Yeah, yes, in terms of the days.
They measure the number of days. So let's say what, it's 365 days,
Make a year, but how do we measure a day?
24 hours in time.
But where did this 24-hour come
Yes. So I can't go any further. Can somebody help me?
Miss Anushi, Anushi, where did 24 hours come from? We just pop it up, sir.
Because 24 hours make up 1 day.
Yeah, but what do we consider a day? How do you know when a day is completed?
Yeah, because it consists of day and night. So when you know that a day, certain hour, certain time has passed, you'd have known that a day has passed. You
Right.
have 12 hours in the day and 12 hours in the night.
Day and night has to do with the sun, seeing the sun and not seeing the sun, right?
Yes, sir.
Yes, sir.
All right. So the day is the time the earth take to make one rotation. You know what rotation means?
Means that it moves from one place to another, one part to another.
Have you ever seen the football player put the ball on their finger and spin it like that?
Yes.
Yeah, that's an example of rotation. The ball spinning on that axis is rotation. The earth is said to be spinning on an axis. And when it goes around one full turn, that is what we call one rotation. And that's what we get 1 day from. So 1 day is one full turn of the spinning on the axis. Right? Following me?
Yes, sir.
Right. And so, but again now, we talk about 24 hours in a day, right? Now, 1 day, just one full turn on the earth. But how do we get a year? We get a year by counting 365 days and a quarter. Where did that come from, Miss Anushi? All right, so Mr. Author says that the Earth orbits around the sun. All right, so the Earth orbits around the sun. Now, there's a difference between the orbit of the Earth around the sun and the sun and the Earth spinning in 24 hours. Do you know the difference, Miss Morris?
If I know the difference between what, sir?
The Earth orbiting around the sun and the Earth rotating.
Not sure, sir.
All right. Do you know when we talk about the solar system and we talk about the planet around the sun, that's
Okay.
what we refer to as orbit. Another name for it is revolution. Ever
So,
heard
sir,
that?
that's I don't remember, but that would be like the same thing, and they're saying that everything around the solar system that continues to move,
Right.
that's orbiting, that's it.
Yeah, are revolving around the sun. So revolving and orbiting is the same thing. If there are times when we have what we call satellite that goes around the Earth, right? We have man-made satellite that goes around the Earth, but the moon goes around the Earth. Did you know that, Miss Barnes?
That the moon goes around the Earth.
Yes.
I would have come to some conclusion to say that it would have functioned somewhat like the sun. So when the sun moves, then the moon.
Right. Now, you would be surprised to know that these movements in these bodies are pretty much what make up our calendar system, right? Because the time it takes for the moon to go around the Earth gives you 1 month. You follow what I'm saying?
The times it takes to go around the Earth gives us 1 month.
Right. The moon goes around the Earth. Like it starts from one point of the Earth and it goes right around the Earth and back to that point. It takes 1 month. That's what we call an orbit, you know.
Okay.
So if you have like let's say you have a lime, you have an orange on a string, or a lime on a string, and you wheel it around your head, and it goes around one time and come back up. That's an orbit. You follow?
Yes, sir.
Right. Now, orbit is different from spinning. Orbit is the movement around an object. But spinning is the thing sitting on a point and spin there, like how the football spins on the person's finger. It spins on an axis, like a car wheel is spinning on an axis, right? And that spinning, if you know what a gig is,
Yes, sir.
not many young people know what gigs are anymore. But when we were growing up, we used to play gigs, and they keep spinning. You wind it up on a piece of card and you throw it on the ground and it spins on the point. And that's what rotation is, when something sits on its axis and spins around. So the Earth does that in 24 hours. But while the Earth is spinning in 24 hours, the moon is actually going around the Earth, right? And interestingly, while the moon is going around the Earth, so the moon is going around the Earth, and then now the Earth spinning, the moon spinning around the Earth, and then now the Earth is going around the sun. You can picture that?
Yes, sir. I'm
Right.
kind of getting it.
Right. So the time it takes for the moon to go around the earth gives you 1 month, and the time it takes for the earth to go around the sun gives you 1 year. That's our system.
Sir, I'm gonna get that. The time that the earth takes to go around the sun.
Right, is what gives you a year. It takes 365 days and a quarter for the earth to go around the sun. And within that time, that's how we get our season, you know. When we talk about spring, summer, autumn, and winter, that's how the season come about. The summertime, the earth is closer to the sun. And wintertime, the earth is farther away from the sun. And so that's why we feel cold, because the closer you are to the sun is the hotter you're going to feel. Further away from the sun is the colder you're going to get. What I'm saying? So Earth does not go around the sun in a perfect circle. It kind of goes around in an elliptical orbit. Yeah, that's why every month is a full moon. So, you know, you're learning some very important things, and as you learn more about physics, you will learn more about these things. Any question in regards to these? And interestingly, that's how our time system come about. And in ancient time, the Egyptian number system, when they come up with their number system, with their meter, when they talk about inches and feet and so on, it comes out of the same system, that 365 days that the earth goes around the sun. That becomes the 360 degree that we get from a circle. And that, and that also become the time system that we use. All right.
But you know what I always wonder, sir?
Yes.
For example, my grandfather, when he was alive, and he would be able to just go out and put his finger up and be able to tell us the exact time of the day. I always wonder, how is it that he's able to do that? And his timing was always accurate.
Right, because you see, it's kind of a physics thing too that your grandfather was doing. Because ancient people find ways of how to map what is happening in the sky at a certain time. Now, you probably heard about the three wise men who went to visit Jesus on the time when he was born. And these wise men were able to find their location based on looking at the stars. Now, time can also be measured based on shadow, right? Now, when you're at a certain time of the day and the sun is exactly above an object, then the shadow, there is no shadow to see. So you find that your shadow is kind of like it disappear at that time. And you could probably safely say it's about 12 noon. You follow what I'm saying, Miss Morris?
Yes, sir.
Yeah, so people usually back in those days usually have certain little techniques they could use to determine the time of the day. Now it becomes a little bit more sophisticated when they start making like a watch, you know, to actually measure time. All right. So, you know, the intention wasn't really to go deep in time, but the thought was, you know, we are measuring these things as physicists, and we, you know, why these quantities become so important to us is that we realize that there are different quantities that we can observe and measure. We can measure length, we can measure mass, and so on. So as scientists, we become really interested in these, you know, phenomenal things. So these basic quantities, length, mass, temperature, time, the amount of a substance, electric current, the luminous intensity, these are all measurable things. Now, we call them basic quantities because when we're measuring these quantities, we can use the device of measurement and we get the exact measurement just by using a measuring device. So if we're measuring temperature, we use a thermometer and we get the exact measurement of temperature. We're measuring length, we use a ruler and we get the exact measurement of length. We're measuring mass. We're talking about the amount of stuff. We can use something like a beam balance or yeah, probably about 3 different types of balance. And so on. So you find that these quantities that can be measured independently of any other quantities are called basic quantities. That's why we call them basic quantities, because their measurement can be independent of other quantity. They don't rely on any other quantity for their measurement. Everybody get an idea of what I'm saying now? Why we call them basic quantities?
Yes, sir.
All right, Miss Morris,
Yes, sir.
you get that understanding?
Yes, sir.
We don't need to have any other quantity to measure these quantities. And their units, the unit of length, and we are working with the SI unit system now. So it means that these are standard when it comes on to measuring. So when we measure in length, we measure it in meters, measuring mass in kilograms, temperature in Kelvin, time is in second, the amount of a substance in mole, and the electric current in ampere. I would have mentioned the name ampere already. This unit comes from the name of the scientist who usually study electric current. Luminous intensity, the candela. Now, when we talk about luminous intensity, what comes to your mind, anybody? All right, so light comes to your mind, Mr. Arthur. Now, what is it about when we say luminous? We're talking about light, anything that are reflecting light or anything that is giving off light, we say it is luminous. Intensity now has to do with how intense the light is. All right. Now, so these are all measurement units for these quantities, and these are their symbols. Now, instead of writing out the entire word meter for the unit, we just put M. Instead of writing kilograms, we put kg. And instead of writing Kelvin, we use capital K. Instead of writing second, we use common S. Instead of writing moles, we just write MOL. Instead of writing ampere, we just use capital A. Instead of writing candela, we just write CD. Now, you have to be familiar with these symbols because when you're writing your measurement, you will have to affix these units to your measurement. Because in physics, if you just do a calculation and write down a number for your answer, it won't make any sense if there's no unit attached to it. Because the units tells you something about what is being measured. What can the unit tell you about what you're measuring? What do you think the unit tells you about the thing that you're measuring? Just by hearing the units, the name of the unit actually suggests what quantity you're measuring. So if you hear meter, that tells you that you're measuring length. If you hear kilogram, that should tell you that you're measuring mass. And if you hear Kelvin, that should tell you that you're measuring temperature. Now, for temperature in physics and in science, we use Kelvin, but we know we have other units to measure temperature like Celsius and Fahrenheit. But for the purpose of science, we use Kelvin, right? Is that clear what I'm saying, guys? Miss Morris, are you hearing me?
Sir, I wasn't hearing you, I just came back in.
You're sounding a little low now, Miss Morris. I can hardly hear you.
I'm not hearing you clearly. You just came back in. So I didn't hear what you said after you said units.
Okay. All right. I think the audio quality is pretty much poor this evening. What I will do, I don't know. I will see if I can have these videos posted at some point that you can get to view them. Maybe you will hear watching the video, right? So we're kind of at the end of our time for the class now. So I will continue from here when we meet next class. Everybody is hearing me. I'm assuming that Mr. Authors is hearing me. Are you still hearing me, Miss?
Yes, sir. Yes, sir.
I'm hearing you just very low in the background. And